Have you ever wondered how you can get a massive power boost out of your car's engine without actually making the engine any bigger? I mean, it sounds kind of like a magic trick, doesn't it? Well, it's not magic. It's actually over a century of brilliant engineering all packed into a tiny spinning metal snail. Okay, let's pop the hood and really dig into how this amazing piece of tech actually works.
So this is the big question, right? This is the puzzle that engineers have been obsessed with for 100 years. I mean, seriously, the first patent for a turbocharger was filed way back in 1905. But, it took decades to really perfect it for cars. The challenge was always the same. How do you get more bang for your buck without more bulk? And the answer, as it turns out, isn't about the engine size, but what you feed it.
To really get why the turbo is so special, we first have to understand how a normal engine works. A standard or naturally aspirated engine. Now, it's a fantastic machine, don't get me wrong, but it has this one fundamental limit, and that limit is dictated by the air all around us. See, it can only suck in air at whatever the atmospheric pressure is, and that puts a really hard ceiling on its power potential. And this right here is the key difference. A standard engine is pretty passive. It's kind of like our lungs just taking a normal, easy breath. The piston moves down, creates a little vacuum, and that just pulls the air in. A turbocharged engine, though, that's a whole different animal. It doesn't just ask for air. It acts like a powerful pump, aggressively forcing it inside. So how does it get the energy to do that? Well, this is where the sheer genius of the idea really shines. A turbocharger takes something an engine normally just throws away, hot exhaust gas, and recycles it. We're talking about energy that would otherwise be completely wasted, and it turns it into a massive performance advantage. It's literally turning trash into treasure. At its heart, a turbocharger is actually a beautifully simple concept. Just think of it as two tiny wheels connected by a stick. On one side, you have the turbine. It's like a little windmill. And on the other side, you've got the compressor, which is kind of like a high-tech fan. They're connected by a single shaft, and they're designed to spin together in perfect harmony. So let's walk through the process. That hot, high-pressure exhaust that would normally just go right out the tailpipe, we're going to put it to work. It blasts against that little turbine wheel, spinning it like a pinwheel in a hurricane. And because that turbine is connected to the compressor on the other end, the compressor wheel starts spinning at the exact same incredible speed, just inhaling huge gulps of fresh air and cramming it into the engine. And that compressed air, what we call boost, is the absolute key to everything. But to really appreciate why this is such a game changer, we need to talk about these seriously insane speeds happening inside this little device. Get this. That little shaft, powered by nothing more than hot air that was being thrown away, can spin up to 250,000 revolutions per minute. That is over 4,000 rotations every single second. It's what allows the turbo to build up so much power-making pressure. It's just mind-boggling. So why does all this matter? Well, by forcing more air into the engine cylinder, you make it way more dense. And denser air is just packed with more oxygen. Think of it like a campfire. The more oxygen you can give it, the more wood you can burn. And an engine, the more oxygen you can cram in, the more fuel you can burn. And a bigger burn means a bigger, more powerful explosion, pushing that piston down. That's where all that extra power comes from. But, of course, there's a catch. There's always a catch, right? It's a pesky law of physics. When you compress air, it gets hot. I mean, really hot. And hot air is the enemy of power because it's less dense, which kind of starts to defeat the whole purpose of what we're trying to do. And that brings us to the next brilliant piece of the puzzle, the intercooler. The hot compressed air from the turbo gets sent through this device, which is basically a radiator just for the air. It chills that air right back down, making it as dense as it can possibly be right before it gets sent into the engine to do its job. It's an absolutely crucial step. Okay, so now we have this incredible system that's shoving dense, cool, powerful air into our engine. But what happens when you have too much of a good thing? What if the turbo is pushing too much air, too much pressure? Well, that's when things can get dangerous. We need some control. This is the logical next problem, isn't it? See, more power creates more exhaust, which spins the turbo faster, which creates even more power. It's a feedback loop. If you just let it go, it would spin itself faster and faster until something breaks. It could literally destroy the engine. And the answer is the wastegate. Think of it like a safety valve. When the pressure in the engine hits its preset limit, a little flap opens up and it lets some of that excess exhaust gas just go around the turbine completely. This slows the turbo down, keeping the pressure right in that safe, optimal range. It's a simple but brilliant solution. And you know that iconic
psh sound you hear from performance cars when they shift gears? Well, that's another safety device called a blow-off valve. When you lift your foot off the gas pedal, all that built-up air pressure needs somewhere to go. So that valve opens up and releases it, which protects the compressor. It's like the engine's letting out a little sigh of relief. So when you put this whole system together, the turbine recycling waste energy, the compressor forcing in air, the intercooler chilling it down, and the wastegate keeping it all under control, you get some truly amazing real-world benefits. So what does all this mean in practice? Let's take a look at the numbers. So check this out. In this chart, a modern, small 2-liter turbocharged engine can easily make the same amount of power as a much larger 3-liter standard engine. But here's the kicker. Because it's a smaller engine, it's way more fuel efficient. We're talking a massive improvement. And that is the ultimate payoff. It really is the automotive equivalent of having your cake and eating it too. You get all the power you want when you step on the gas, but you get the great fuel efficiency of a small engine when you're just cruising. It makes the whole package lighter, more compact, and just way more efficient.
So when you really think about it, taking wasted energy, recycling it to force feed an engine with dense, cool air, all to create more power from a smaller, more efficient package, you have to wonder. So the next time you hear that telltale whistle of a turbo, you'll know it's not just about speed, it's about 100 years of engineering genius, all packed into